Hi, folks. I'm Adrian Sanabria, the host of Enterprise Security Weekly. Every week, we interview the most interesting folks we can find, talking about the most pressing cybersecurity issues and challenges facing the enterprise today. Myself and my co-hosts have each been in the industry for decades, long enough to see the patterns in the industry and explore where trends are going. In addition to enterprise challenges, we also follow the vendor space, the most interesting security startups emerging, technology and product trends, all the most interesting funding and acquisition announcements. Finally, we love to discuss the latest trends in tech and how they'll impact cybersecurity. If you're wondering how the latest in AI, quantum computing, cloud, and DevOps is going to impact security a few years down the road, you should follow the Enterprise Security Weekly podcast.
Welcome back to Application Security Weekly. We just talked with Ali Mellon about generative AI and the ways it can be useful for knowledge creation and working with APIs. She gave us a great examples of how to take a realistic approach towards AI. I was going to say application security. She gave us that too. I'm your host, Mike Shima, who's not in AI, as you can tell about my excellent enunciation through here. I'm here with Farshad Abbasi, who's hopefully going to speak a little bit better than I can. And Farshad, we've got a handful of news articles to go through. As usual, going to kind of work from some vulnerabilities into some more thinking aspects. And for this first one, we've got someone who was hacking a traffic control system. And I thought it was going to be interesting, and it was going to have some fun hardware things that John likes to hear about. But I think second paragraph in, the researcher says, I got this traffic control system. I thought, I'll try a web app vuln, and in 15 minutes had an authentication bypass. So sort of game over already. You can do anything you want. And once again, web app vulns strike. So the takeaway there is a little bit. Yeah, and the takeaway was about actually still in this day and age, the year 2024, still running into, a response from the legal team saying what exactly you're doing. How did you get access to this? This is a legacy system, so we're not going to acknowledge, basically a very bad experience in vulnerability disclosure. And that's the part where I do have to shake my head that those are hurdles that are tough to get over.
Yeah. And a lot of these traffic control systems are increasingly connected to wireless, makes them fairly susceptible to these attacks, right? And it's that classic industrial control system, IoT discussion that, Mike, we have all the time in the security world, right? Where these devices are often old, or they don't have enough capability, or people build them really quickly, not really paying attention to security because they're like, hey, they're used in proprietary networks. Who has access to these networks, right? But we all know what the answer to that is.
We do. And especially that aspect of here's a vulnerability in an ostensibly legacy system, even though legacy often still means up and running and supporting, revenue, business functions, etc. So that part is definitely not a concern that's specific in this case to, light traffic controllers. But it's like how as we as AppSec teams have that conversation with engineering teams about, well, this is legacy and it really needs to go away, or we need to have a timeline to get rid of this because keeping it around is just increasing our risk.
Yeah, I mean, and I think the biggest benefit will come through education. I know if there was a course that I took back in the university when I did my comp sci that was like, hey, this is about security, and it taught us all these kinds of things, I would have come out with that mindset. But unfortunately, in many institutions, educational institutions, that is not the case. Hopefully, that will be more and more so. I've seen movements, and they're introducing cybersecurity courses at the high school level in some states and other places. But the university I attended still doesn't have security courses that teach people how to do this stuff better.
No, indeed. And I'm going to jokingly reply that we also have the MBA side of things who are going to point out, well, we still need to run a business. We have to generate revenue, and the system is legacy. And I'm trying not to talk about the specifics of CrowdStrike too much, but I think it was funny. Anecdotally, I read Southwest is still running Windows 3.1 and Windows 95 for a lot of their internal operations, which just so happened to keep them protected from, a legacy version of Windows that didn't get affected by that. So that was fun. But instead of talking about legacy things, let's turn to the future of artificial intelligence, Farshad. And here's an article from a blog post from Wiz, who were talking about SAPwned. And this is SAP AI vulnerabilities, expose customers' cloud environments. Now, to me, this is there's some interesting and less interesting, less exciting things about it. The interesting thing is, in general, everybody's just looking for AI. And they want to pick apart AI. They want to look at how is this AI system working. And honestly, this blog post worked on me because it caught my attention. But a lot of the problems they're identifying are really just about general Kubernetes configuration, lack of strict tenant isolation. It's more of just rather we could just say, here's some code that you're running in a shared environment, and that code, that shared environment had some weaknesses that we could bypass. They could get in, basically they couldn't be run as root, but they could change their UID to LEET, which was a really fun 1337 of the Istio UID. So that was a really fun and real Easter egg within the write-up. But they're gaining unauthenticated access to EFS shares. They were finding Google Access tokens, AWS secrets. These are things that have nothing to do with AI, really. These are basic AppSec, right? Yeah. And I think we were talking off air after our conversation with Ali and mentioned that there is, in fact, a top 10 list for LLMs. So, we do actually have OAuth diving into that. And we actually had Sandy Dunn on a couple months ago to talk about this top 10 list. And Farshad, this had come to mind in our conversation and kind of might apply here too. Tell us a little bit about why that top 10 list came to mind.
Because we were talking about certain issues with AI, but really it's about how are you using it in a way that doesn't end up compromising your application. So things to consider while you're building the application to make sure that it's a secure way of using that AI or any LLM, in fact.
And that's what stood out to me too, is that most of the items on the top 10 list are really just kind of, as you alluded to, you're just running some code. And something like prompt injection, okay, that's pretty LLM specific, although in spirit, cross-site scripting is an injection, command injection, SQL injection. There's still a separation of data and code. It's just LLMs are much more ambiguous about where that border is. But insecure output handling sounds exactly like cross-site scripting. Exactly. Sensitive information disclosure, insecure plugin design, denial of service, supply chain. This is software, right? That's not LLM.
It's funny, Mike, that you mentioned that, because there's also the OWASP top 10 API security risks, but when you look at it, you're like, these are pretty much standard application security issues, right? And I think it's kind of a reminder, same with this SAP AI problem, is that sometimes it's just your standard practice. Right here is like segregation, right? Segregate, isolate. This isn't AI specific, but you have to also think about it when you're running a model, because that model is processing, everyone else's data in case of this SAP situation, right? So again, going back to those classic, considerations of segregate, make sure people's data is separated, make sure if that one area of the application is contaminated, if you will, that people can't pivot to the other areas or get other people's data. But yeah. Good reminder.
And it's the idea too, especially in the SAP example, the Wiz blog post, it's pointing out this was a lot of this, the underlying architecture was Kubernetes. And so you do have to ask yourself, how much is Kubernetes a security boundary, a security, and how reliant would you want to be on that versus other methods of network segmentation, compensating controls, other types of controls, as you're pointing out.
Yeah, we had this concern, like I worked at HSBC for a long time. We had this concern about our data getting processed by the models that are processing everyone else's data as well, particularly Google. Can't remember which service it was. But the solution at the time wasn't available. This is like 6 years ago. But now we have commercialization of homomorphic encryption. So that's one thing that could be used so that while your data is out there being processed, it's processed and encrypted. They can't see it, but they can still process your data. It doesn't work for every application, but it does work in many, many cases. And I think that was the direction that we were going, utilizing that type of technology.
And there's definitely a lot of complexity both on the cryptography side, as well as the emergence of confidential computing in the last year or two. I recall, these are the articles that we've come across, and just recently the Apple Intelligence, their version of AI, but talking about how do you do workloads in the cloud, that, as you said, are just isolated, are not learned from, and not exposed to the cloud admins. So these are the more secure designs that I think aren't really captured in top 10 lists. And that's a little bit of, for those listeners who have listened a while, they see my also a top 10 list skeptic, or a realist, if you will, to use Ali's language, that we need something that's better to push us to secure designs rather than just say, don't write bad code. In the spirit of don't write bad code, I wanted to bring up part 2 of a article from the OpenSSF that we covered part 1 in a week ago or so about the AI Cyber Challenge. And they were using the Needle Linux kernel vulnerability as just kind of a demonstration for the upcoming Cyber Challenge semifinals at DEF CON this year, to say, here's a Needle Linux kernel vuln. How easily might a AI, some type of analytic engine, find this? Because it's relatively simple, straightforward. The vuln itself is a single line of code. It's all, the context is all within a single file of code. And this part 2, they're talking about how do we fix it? And what's interesting is, as a callback to our conversation with Ali, AI, generative AI, seems to be helpful, but not fully trustable. So in this, as this article points out, the fix, which is basically fix the arithmetic in a particular line, some of them got them pretty right. Some of them also widened the data types. They went from an 8-bit to a 16-bit data type, which can work, but is not it does have some pitfalls if then you shrink that back down to 8 bits without being careful about overflows. So and it's an interesting just walkthrough about this is the type of problem that we're going to see these run into. And Farshad, in the last segment, you also mentioned just using AI to help work with an API, but you didn't stop there. You didn't just trust that code, right? This was like somebody was just being helpful. So
100%. And I think
tell us more about that.
Ali made a really good point. You can't, when she was talking about giving that tool to the junior developers to, hey, we're going to enable our junior developers, that can be a mistake, because oftentimes, at least in its current shape or form, these things make things up. So if you don't have the expertise to go and actually look at it, it may be a problem. I've even found sometimes it takes me longer to use an AI tool to do something that I normally do, because I got to go and read it and then, oh, this is not correct, fix this, it makes a mistake somewhere else. A lot of these models only give you 8,000 tokens, so it forgets all the other things that it wrote before. It rewrites all the things that were correct. So I'm like, wait a minute, I could have just done this a lot faster. But I see a future where that won't be the case. But at the moment, people should keep that in mind. You should have the expertise to review what it puts out to make sure it's correct, and also research it. Go look it up. Like, did it actually give me a real, API, a real function, or did it just make this up?
Well, and I'm glad you added those examples at the end, because one of the talking points, I'll say, premises of generative AI within the vulnerability management space is that it's tedious to go fix every single vuln. That's taking up a lot of engineers' time. So what if we just have generative AI create the fixes? But if we're shifting the engineer's time from writing the fix to then vetting every single fix, it doesn't sound like we've actually made their lives any better, right? It doesn't sound like we've actually given them value. And so here's then, I want to then, as I continue our journey through articles, another segue into an article about, this is from Krebs on security, talking about the weak security defaults that enabled some Squarespace domains hijacks. Now, this one came to mind as a little bit of just wait, that simple is bad is what the problem was, which was Squarespace had roughly 10 million domain names. They purchased them from Google Domains, which basically shut it down. And then in this transition, Squarespace said, okay, every owner, you need to come back and reclaim your domain. And you could do that through kind of those social logins, continue with Google, continue with Apple, the OAuth, or even hopefully in this day and age, passkey-based type of authentication. Totally. These are good things. But they also allowed, continue with email, basically sign in with your email, which you would think, hopefully you and I, Farshad, are thinking, okay, cool. You own the email, so you're going to get something back that verifies the email. That, of course, is not what happened. And that's how you didn't have to actually demonstrate ownership of that email address in order to continue to log in and claim that domain. And therefore, there were a bunch of domain takeovers. A lot of it hit the cryptocurrency community, phishing, blah, blah, blah. things went terrible. But what stood out to me, aside from, wow, that seems like a basic thing. How do you not verify ownership of the email? But I'll also say, how does an LLM identify that as a flaw? Because there's a context there in the code that is more about the business context and a business workflow rather than, oh, you're missing the send this confirmation link to a user on line 32. That type of simplicity doesn't exist, I think.
I guess I could process you could give it the overall process. Hey, I'm planning on designing this feature that allows people to transfer domains from Google to Squarespace. This is how I'm planning on doing it. I'm just going to use the email to verify it. And then the AI, the GPT will tell you, hey, they might do X, Y, Z. Maybe you should enable 2FA. It would at least give you some recommendations. And then you could do something or not. You could say, well, actually, my business context, I don't want people to go through the 2FA. It's too much work. I'm accepting the risk. But I think in this case, there was probably no analysis done, no threat modeling. Let's talk about threat modeling, right? If they'd done that threat model, they would have figured that out. But I don't think that part was done. It's one thing to say, hey, my business doesn't want it as a hindrance to the user experience, knowing that. But it's another not to even know what the risks are and just go ahead with something.
Yeah, and you highlighted, I was going from that, I started that because of the previous article about, AIs finding and fixing code, and you shifted helpfully into the AI as that threat modeling partner. Because one of the things that, one of the challenges I've seen with threat modeling is it doesn't scale very well.
Yeah.
You can't get everybody in a room for an hour. Let's just talk about things. How do we feel about our application? What could go wrong? It can be educational. I see value in that. And, as you were pointing out too, there still seems to be a lack at the, especially high school level, college level, about just general, attacker-minded thinking is 100%. The way I like to phrase it.
100%.
So there seems value there, and maybe, an AI can help to be a threat modeling partner. But then how do we know if I say that if I come in as the junior, and Farshad, you give me that threat modeling generative AI, how do I know that, they should have asked me about, well, did you confirm that you own this email? And
I think this goes to what Ali was alluding to, is it needs a lot of context. You need to give it business context. Without that context, it's not going to be as useful. And that context is often not going to come from that junior developer. Let's talk about how things are done manually today. When we go and do a risk assessment, I don't sit down. Sure, I'm doing a risk assessment on the software that the developers built, but I don't sit down with the developer in the beginning to get the context. I sit down with the business owner. I spend an hour with the business owner, do a business impact assessment. They tell me all about the business, the data, what can happen, the use cases. Then I take that. Then I work with the developers to actually do the threat model with that context that came from the business owner. So even with an AI tool, I think whoever owns that application would need to sit in front of it, inform a bunch of context, and then the development team can leverage that. And then, hey, these are the threat scenarios, developer. You should think about it because I was given this context by the owner.
Yeah, and I think, and I love how you phrase that too, because I've also seen threat models go in very unhelpful or overly specific directions in the sense of
Microsoft modeling tool.
Now, come on. but actually sitting aside the tools themselves, I even mean the content areas of focus. So, it looks like, we're going to take user generated information. Okay, you have cross-site scripting. And then you get into the ideas of where are all the places you're going to deal with cross-site scripting. That to me isn't a fruitful threat modeling discussion. That is more fruitful as, do you have a framework? What is your coding style? What are your tools to identify that types of vulnerability? What's more fruitful is, what are people uploading? Can this be abused? A little bit of getting that trust and safety aspect, if you will, that we talked about with Ali near the end, or just what is the business purpose of this? Are we selling tickets to the Taylor Swift concert? There's a very easy conversation. So you're not worried about injection, SQL injection, cross-site scripting. You're more worried about, is someone going to get all these at once and go for resale? That type of what's attacking the business of your application. And that's, I think, too, part of where my objections or my disappointments in something like the OWASP Top 10 is they're very specifically technical that a lot of those I feel should be addressed by linters, frameworks, that can just help us get rid of a lot of these very specific types of vulnerabilities. Let's have those richer discussions about the business logic, business workflows, and I'm also leading to secure design. And how do we say, oh, here we're using a lot of AI, we're running people's AI models within a shared Kubernetes environment. What should we be worried about? Is Kubernetes sufficient enough? What other segmentations should we have? As I'm obviously trying to do that callback to that Wiz article. But there was then, I think a lot of what we're talking about then is also investment. And that was, we talked about time and money in the segment with Ali about the cost of generative AI. Vendors are still figuring out how to charge for it. And here's an article from Phil Venables, When Good Security Fails, the Asymmetry of Infosec Investment. And it goes through a lot of patterns that are probably familiar to many of our listeners. Basically, you invest in security and quote unquote, nothing happens. You don't see breaches. You don't see any significant outage, things like this. And they think, oh, well, we can now lessen our investment because we're protected. Or getting into how do we deal with, and here is something that's more difficult that I think that I haven't seen a lot of places do personally, is that this zero-based budgeting. Say, everything you do has to be justified. Now, that doesn't necessarily mean it has to demonstrate revenue, but it has to contribute to revenue in a way, or has to contribute to better developer experience, something like that. And so I thought this was a good article that speaks, I think, a bit, it's a larger umbrella than AppSec, but I think it speaks to the AppSec angles of, if we already have 2 SaaS tools, do we need a third one? Do we need to now add an SCA tool? It's sort of like, are we adding tools, or actually we adding value? And what are we fixing, or how are we figuring out what to fix? So that's what starts that's where my mind starts to go when I read an article like this. I'm not sure, Farshad, how, what your perspective, what you bring into this then.
I haven't had a chance, Mike, to read the article, but I do agree with what you mentioned.
And so another one is that maybe helping out generally, the one of the things that this article talks about is delivering and communicating incremental benefits. And I think this is something that you've probably had experience in, and that this is a takeaway that I think can be valuable for AppSec teams in the sense of, when you talk about, let's talk about vulnerability management, something near and dear to my heart. Do you talk about, we found some volume, we found 10,000 CVEs and we fixed 8,000 of them, and 2,000 of them are beyond the SLA, and our poor engineers, they haven't fixed them within our 30-day deadline that we mandated. That is a possible way to communicate, but already, Farshad, I see you shaking your head, and I agree. That doesn't seem like the healthy way to communicate. You're just talking about volume, activity.
Exactly. What did you fix? What business value did it bring, right? Again, right. I worked at a bank for 9 years, so I was brainwashed into thinking everything is risk. You've got to take a risk-based approach, and I believe that's the right thing to do. I mean, I know even Gartner and all these other industry experts are saying that the industry is moving towards risk-based management of vulnerability. It's not about the numbers. It's did you reduce the business risk in the areas that it mattered? That's really what we should be tracking, rather than how many vulnerabilities, how many severities we fixed. None of that has business context. You may have been fixing 1,000 things that brought no value to the business. So really doing that threat model, doing that risk assessment, figuring out, am I fixing the vulnerabilities in areas of the highest risk is present, which is going to require business context.
Yeah, and that's where that narrative can come out of, rather than here's the volume of things we fixed, we did that risk-based approach. So we said, well, there were 10,000 CVEs, but here's this small cohort that was only in our AWS environment for some of the critical systems or revenue generating services that we really care about. So that's where we focused on those. And then call back to threat modeling, we also noticed that this group of CVEs, or these types of misconfigurations, could have actually been fundamentally addressed if we had a platform engineering team, or if we had a cloud security engineering team change some default within our environment. So we got rid of an entire class of vulnerabilities. And so rather than saying we assigned all of this 100 vulnerabilities to 100 different engineers, we actually we didn't even need to assign these vulns to our engineers, because we either negated the risk or we addressed them in a more fundamental way. And that to me sounds like the more mature way to approach that conversation about how do you communicate incremental benefits rather than just going about, time and volume. And then I'm going to pause here, take a deep breath, and yes, CrowdStrike, we've been joking a little bit, the last segment, this segment already, and we don't have, at least that I've seen yet, a full postmortem on it. So I think rather than just say kind of a generic test your code, like that's what honestly everybody's saying. And I think there are nuances there about what is being tested, what wasn't tested, how were tests missed. That's what I would love to have a more deeper conversation on rather than just say test your code, because easy. So for me, I guess how I wanted to approach this, Farshad, was looking forward in the sense of would love to see that postmortem of that timeline of what went wrong. And with the idea that, I would hope testing of Zubzord is in place, but what went wrong? Like, how much of this was a tooling, a process failure, which is related to tooling in the sense of you've got stage rollouts that perhaps started in Australia and then, spread throughout different time zones, if it's, time-based, or spread through regions. How were certain canaries not seen? So this is where I would love to see that transparency in a postmortem.
I'm curious to know about what kind of controls they had in their development pipeline, right? Because, it's funny, Mike, I'm sure you've seen all the memes, right? There's some memes that are like, oh yeah, junior developer just felt like deleting everything and optimizing the code, and then things blew up. Like, if you had pipeline security, one of the things is, when you do a pull request, there should be a manual code review, and then there should be X, Y, and Z. Like, all kinds of things should have been in place to catch this type of thing. Was this a single person able to just check something in and blow everything up? I doubt it. But yeah, like yourself, I'm really curious about the analysis that'll come out of this.
Yeah, and part of the reason I was curious about the transparency is that we've seen on different scales, but we saw just a couple early this year, Google Cloud deleted a customer's entire resources. And that was, I think to slightly paraphrase, that was a code path that they were surprised that they had, never encountered before. So it's one of those black swan events, very rare. And they had testing in place, obviously, through, they've done thousands and thousands of deletions and deploys. This just happened to be that one thing where, the planets align and there was a process failure, a bug in code. I would also draw parallels to Heartbleed and Shell Shock in the sense of, here's our ecosystem being hit by a certain type of vuln. And the reason I bring those two up is, Shell Shock was very much a surprise.
Yep.
That was an old bug that people suddenly found within the Linux world.
Yep.
And so Heartbleed also was something that was, the reason I bring that one up is that people also said, ooh, maybe we do need to do something different from OpenSSL. And we saw growth in a bunch of different TLS stacks after that. So that's why I wanted to use this CrowdStrike conversation as a lesson, not so much to poke the eye of, should have tested your code, here's a bunch of fun memes, but more of like, what are actions that are concrete that we should be taking from this that feel valuable?
Yeah, 100%. What do we learn from this and the other breaches? Yeah, for sure.
So I'm sure that CSRB picks up on this one as well. I'm pretty sure this one will be, they'll get to pick on someone, not just Microsoft, but unfortunately for Microsoft, still Microsoft adjacent. So
a lot of people were impacted.
A lot of people are impacted. But thankfully we were not, and you were able to join me this Monday, Farshad. So I appreciate that very much. Thank you.
It worked.
It worked. Also want to thank everyone for joining us. Please do remember to subscribe, share on the socials, check out the show notes, and speaking of human beings, check out Radio by Thought Beans. We'll see you next time on Application Security Weekly.